Okay, good morning everybody. Welcome to the User Day 2011. I will only spend 10-15 minutes talking about some more general things because we have a lot of extremely good talks and discussions and so for the rest of the day, so I don't want to bore you for too long. First question that I have. How much power do you think the jet d'eau in Geneva uses? You can think about this. I'll come back to the end. So this is the slide I've been showing since 3 years, more or less, since actually, yeah, I joined the CSCS more or less 3 years ago, not quite three years ago, and we were, you know, at the time, yeah, this was 2008, so we had this Cray XT3. In the meantime, our main computer is Monte Rosa. We have this program, this high performance, high productivity computing platform, HP2C, that has now been running for 2 years and is going to go into its third and final year in 2012. We are running the final upgrade to Monte Rosa this fall, and I believe there will be some information about this later today that you will hear about the details, because this is now going to be a reality. And we are going to launch a new series of procurements that will start in 2012. The details I don't really understand myself yet, but we are working on it. So I'm sure by the time we have the next event, you know, we will be talking all about that. We also, and this is one thing I've been saying, in order to run these new systems that are going to be significantly bigger than what we have been running so far at CSCS, we needed new infrastructure, and so the new CSCS building is now reaching completion. We expect that we will probably move into the new building sometimes in next spring. So everything I can say is still on track. The other actually piece of good news that we have for the computational science community is that in July the ETH board basically approved the continuation of this high-performance computing and networking initiative beyond 2014. So what you see here, this is all this HPCN initiative that was approved by the Federal Council in 2009 and also by Parliament in 2009. And so this is basically funded through 2014, and the ETH board is now pretty much completing the budget cycle through the end of 2016, because that's the federal budget cycle, is a 4-year cycle. So I think, you know, for this big high-performance computing-oriented computational science community, I think the current decade that we are in is going to be looking very good, at least from the infrastructure side. Now you are responsible to make something that is worth the investments out of it. So this is really the news that we have generally. Now, from a CSCS point of view, we are basically continue to refine our approach to high-performance computing and computational science. And I'm trying to show this on this slide here. What you probably already see from this HP2C program is that what we are going towards is to go to a model where the scientific use cases determine the systems that we are going to be procuring and operating at CSCS. This is really a step away from how HPC centers, traditional HPC centers work, where you buy buy hardware and then you look what you do with the hardware afterwards. And if you're lucky, there's some really interesting things you can do. And if you're unlucky, you're just going to continue to do old stuff or dull things. So what I want to capitalize now on the HP2C program and really use the fact that in Switzerland we can define finite, well, these sets are always finite, but a manageable set of communities that we can basically work with, use their scientific, their input on what their use cases are. So that's what I mean by these communities. And I'm being politically correct. I'm not naming anybody here. That's one thing I learned very early here, that in Switzerland, that you have to really it's better to talk in the abstract. There's a number of special customers that we have, like Meteo Suisse, Blue Brain, this is the CHIP, the high energy physics community that operates systems. So we use this input from scientific use cases. We use input from vendors on what is available. And then we have our research effort, scientific computing research effort at CSCS, which we will now basically explicitly split into community engagement. So people like Will Sawyer, Claudio Geller, and so will be sitting here. And we have an explicit future systems effort. They work with this input to create the systems that are then going to be integrated into the national center. Of course, the systems will still be operated in the way we do it today with peer-reviewed user projects. But as I said, there will be a lot more involvement in defining the directions where we are going. So we're really going to organizationally move HP2C like projects. So there will be more, and we will continue this type of operation into the future. And so from the CSCS organization, starting in October, we will have a slight adjustment. So we still have what today you call national computing, the national service, the technical support, so Maria Grazia and the people that maintain Monte Rosa and the people that maintain the Meteo Suisse system, they are still here. The scientific computing research will be split, as I said, into this community engagement and future systems, and my batteries are fading away. So that's just when you look at CSCS org charts also in the future, that you understand why things have been adapted slightly. Again, the main philosophical difference is that we want to really capitalize on these very large developments that we have going on in Switzerland and work very closely with those in terms of defining what type of systems we will have in the future. And we are also leaving open whether this will be one system or two or three. It is going to be an optimization process between what we need to do the science we want to do, and that's defined by the Swiss scientific computing community, and on the other side, of course, what is implementable within the budget framework that we have. But compared to other countries, I think in Switzerland we have an extremely attractive budget framework, but it's still not infinite. So you still have to implement a computer in the real world with, within a reasonable power envelope. And so that's getting me back to the question, the much talked about power envelope that we have when we talk about high-end computing. So Monte Rosa is within a 700 kilowatt envelope today. When we go into the new building, we will have about a 10 megawatt envelope initially that can be increased, of course, could be doubled in principle if we need to. But when we talk about megawatts, you have to realize we talk about roughly 1 million per year for 1 megawatt, just in not infrastructure, but in power bill. And so, you know, when you talk about doubling from 10 megawatts to 20 megawatts, you talk about adding 10 million just to the power bill of your budget. But it turns out the jet d'eau, when you go on Wikipedia, you can see they have 2 500 kilowatt pumps. So this thing is using more power than Monte Rosa. And so if anybody of you has a you know, bad conscience, or some journalists are trying to talk you into you know, that we are not green or whatever, those tourists who look at this thing, you know, use as much power as you guys when you run your scientific enterprises. So that's all I had to say.